Okay, this is number 5 on 7.1. Well, there's lots of interesting things we can do with this problem, or that we're going to have to do to figure it out. And the first thing is we want to find out where it's moving right, left, or stops. So we'll find out where it stopped first. And we just have to set v of t equal to 0. So if we write this out, set this equal to 0, we have the sine square root of t 5 times that, cosine of t equals 0. Well, this is going to be 0 either when the sine of t squared equals 0 or the cosine of t equals 0. So that's just going to be where the sine is 0 or the cosine is 0 on this interval. So the sine would be 0 at 0, pi, or 2 pi. And the cosine will be 0 at pi over 2 and 3 pi over 2. So we can look at this velocity line that we did before. It's going to be a little bit bigger, and we're going to go from 0 to 2 pi and pi over 2, 3 pi over 2. And these are going to be our 0 points. I kind of want to figure out what the signs are going to be here so I know whether I'm going left or right. So this is where there's lots of ways to do this, but I just can look at the graphs here. Now if we draw our graphs here on the right, there's our 0, 2 pi, and this would be pi over 2, and 3 pi over 2. And this is going to be the sine. Then right below it I'll put the cosine, because remember that we're taking their product. So sine squared looks something like this. If this is going up 1 and back down 1, sine squared looks like this. But since we square a negative, we get a positive, so it's going to look like this. So the sine squared kind of looks like this. Now the cosine, that starts up here at 1. In this case it'd be 5. It basically behaves the same way. Goes down, looks like that, so that's the cosine of t. So if we look at these graphs, we can tell from here we've got a positive times a positive, because this is the product. So a positive times a positive is a positive. Now in this range we've got a positive times a negative, because cosine is negative but sine squared is positive. That's going to be negative. And over here we still have a positive times a negative, so it's going to be negative here. And then finally in the last quadrant, or the last 90 degrees, we've got a positive times a positive is a positive. Okay, so we're moving right when it's positive, so we're moving right. Okay, when it's 0, now we're not at 0, we're 0, so we have to use open intervals, so we're going right at 0 to pi over 2, and over here 3 pi over 2 to 2 pi. That's when we're moving right. We're moving left when it's negative. So that's going to be pi over 2. Now not all the way over here because we stop at pi. So it's going to be pi over 2 to pi, and then pi to 3 pi over 2. And we just stop for a moment at pi. And we're stopped at these points: 0, pi over 2, pi, 3 pi over 2, and finally 2 pi. That's where we're stopped. So there's a bit to that A part. Okay? Now the B part, we want to find the displacement of all this. So this is the B part. Just a little more room up here. Use all this paper. Okay, so the B part, again, as we did in the first two problems, V of t equals ds dt. That's going to be the actual integral. So we can separate this like we did before. So there's my velocity function, 5 sine squared t cosine of t. I'll separate my variables, so I get ds equals 5 sine squared t cosine t dt. And I can integrate both these from 0 to 2 pi. Hope you can see that okay. And again, this is just going to be my displacement. We can call that delta x from 0 to 2 pi. It's going to be my delta s, and that's going to equal this integral, and we can evaluate this. Now, if we look at this, and I kind of separate it like this, I'm going to kind of rewrite this. I better rewrite this so it makes a little more sense. 0 to 2 pi, and I can bring the 5 out in front. And then I can write this as the sine of t squared times the cosine of t dt. Then this looks like u to the n du. If this is u, the sine of t, what's the derivative of the sine of t? That's just cosine of t dt, so that would be my du. So this looks like this is u to the n du, or u squared du. So if we take the antiderivative of that, that's not going to be too bad. That's just going to be 5 times u to the third over 3. And that's going to end up being 5 times the sine of t to the third power over 3. And then we're going to evaluate that from 0 to 2 pi. Well, what's the sine of 2 pi? Well, that's 0, so I got 0. And what's the sine of 0? 0, so I got 0 minus 0. Or if you want 5 times 0 minus 5 times 0. Either way, we have 0. So we end up kind of going back and forth. So we go a certain distance here to the right, then we go to the left, then we go to the left a little bit more, then we go back to the right, we end up where we started. Look at this. Okay. So again, as they said, if s sub 0 equals 3, okay, and my displacement is 0, then my final position is delta, well, I should say s sub 0 plus delta s, so that's going to be 3 plus 0. So 3 is your final position. So that's your final position. Okay. Alrighty, and finally the last part of this problem. We want to find the total distance traveled. This is 5C, pardon me. Thinking ahead. Okay, so the total distance traveled. Okay, so my total distance traveled is going to be the integral from 0 to 2 pi of the absolute value of this 5 sine squared t cosine t dt. So I have to take the absolute value of that. So again, we have to be aware of where it's positive, where it's negative. So we have to be looking at this chart here. So from 0 to, let me get this up a little so you can see it. So here I'll be taking the positive integral. Here I'll take its negative because it's negative, so remember the absolute value of x is negative when x is negative, so I take negative the integral, then positive. So break it up into 3 parts. So this absolute value will be evaluated as the integral from 0 to pi over 2 of 5 sine squared t cosine t dt, and then minus the integral from pi over 2 to 3 pi over 2, 5 sine squared t cosine squared, cosine t dt, and then I'll put it over here plus the integral from 3 pi over 2 to 2 pi of 5 sine squared t cosine t dt. Alright, so that's what we've got to find out total distance traveled. Now I'm going to take all these 5's out, so I'll pull all these 5's out. And remember, we already took the antiderivative, so we know the antiderivative of this is going to be u to the n du. So it's going to be sine t cubed over 3, and that's going to be evaluated from 0 to pi over 2, minus, and there's kind of a big parentheses about that because it's all multiplied by 5, sine t cubed over 3 from pi over 2 to 3 pi over 2, and then plus finding this last one, sine t cubed over 3, and that's going to be from 3 pi over 2 to 2 pi, and that's all going to be multiplied by the 5. So this is going to be 5 times, and the sine of pi over 2 is 1, 1 cubed is 1, so I got 1/3, minus sine of 0 is 0, okay, minus, and now this is going to be negative 1, so negative 1 cubed is negative 1, so that's going to be negative 1/3, minus, and this is going to be 1, so at pi over 2, the sine of pi over 2 is 1, so that's going to be 1 cubed, which is 1, so that's 1/3. And this is going to be plus, and then the sine of 2 pi is 0, so that's going to be 0. All right, minus, and then the sine of 3 pi over 2 is negative 1, so negative 1 cubed is negative 1, so it's going to be negative 1/3, all multiplied by 5. That's going to be 5 times, and that's going to be 1/3. Now a negative 1/3 and a negative 1/3 is a negative 2/3 times the negative is a positive 2/3, and that's going to be a negative times the negative is a positive, so that's going to be positive 1/3, which equals 5 times 4/3, which equals 20/3. So there you go. That's one heck of a problem. Hope that helps. Number 7. Maybe you can do number 7 on your own. I don't know. If I have time, I'll do number 7. It's getting kind of late. So good luck.